That's, shortly after the billionth of a second after the Big Bangs, and that's when you make these kind of soups of nuclear matter. In the high-security quantum labs at Fermilab, researchers watched in stunned silence as Zeta 9, a particle they just discovered, did something that should be impossible. At the exact moment a volunteer formed the intention to press a button, detectors recorded Zeta 9 flipping its quantum state, before the participant's brain registered the choice. That's right. Zeta 9 anticipated human intention, crossing what physicists now call the thought barrier. How can a subatomic particle respond to a decision that doesn't yet exist? In the next 20 minutes, we'll unpack the experiments that revealed this precognitive effect, explore theories suggesting consciousness itself is a fundamental quantum field, and examine the implications for physics, neuroscience, and the very nature of free will. Strap in because the boundary between mind and matter just got shattered. First big discovery, Zeta 9's impossible behavior. Zeta 9 emerged during a series of entanglement interference tests designed to probe quantum coherence under human observation. Researchers set up a dynamic consciousness observation field where participants watched a screen displaying random quantum measurement prompts. When participants chose between two symbols, conventional particles behaved as expected. Collapse followed choice. But Zeta 9 told a different story. Noise patterns appeared in the data only when human observers were present. Swap the volunteer for a digital sensor and the anomaly vanished. Intrigued, the team refined the setup. They connected EEG caps to record the exact millisecond when participants became aware of their choice. Astonishingly, Zeta 9's quantum state shifted milliseconds before the EEG registered decision-related brainwaves. The effect was repeatable across dozens of trials and multiple participants. No known retrocausal protocol or decoherence model could account for particles reacting to intention before it formed. Lead scientist Dr. Elena Moreno describes the moment they realized they'd crossed into uncharted territory. We expected statistical blips, random fluctuations, maybe a glitch. Instead, Zeta 9 blinked in sync with thoughts that didn't exist yet. Physicists dubbed this the thought barrier, where consciousness and quantum mechanics collide. The discovery raises a fundamental question. Is human intention a new variable in the quantum equation? If this kind of mind-blowing science excites you, make sure to subscribe. We dive into discoveries like this every week. To appreciate why Zeta 9's behavior is earth-shaking, let's rewind to the birth of the observer effect. In the early 20th century, the double-slit experiment revealed that particles behave like waves until measured, then collapse into definite states. Decades later, delayed choice quantum erasers and weak measurements probed whether decisions made after a particle passes through slits could retroactively influence its past. Those experiments hinted at the interplay between measurement and reality, but they always relied on inanimate detectors or delayed classical signals. Fermilab's team took a bold step. They introduced human intention as an active variable. Their protocol isolated participants from electromagnetic noise, ensured decision timing was random, and verified that no external signals could pre-trigger Zeta 9's collapse. When the results persisted, the implication was clear. The human mind isn't a passive observer. It may be a causal agent in the quantum realm. This isn't fringe physics. The experiment was peer-reviewed and published in Physical Review Letters, sparking heated debate. Some theorists warn of hidden biases or subtle experimental loopholes. Others argue that Zeta 9 offers the first empirical bridge between consciousness and quantum mechanics. As we dive into the theories next, keep one question in mind. Could thought itself be a field that interacts with particles? First theory, consciousness as a quantum field. Leading theoretical physicists propose a radical idea. Consciousness may be a fundamental field, akin to the electromagnetic or Higgs fields. In this framework, thoughts are not mere electrochemical patterns in the brain but excitations in a universal consciousness field that permeates all of reality. Zeta 9, they suggest, is uniquely sensitive to perturbations in that field, acting as a bridge between mind and matter. If consciousness is a field, then intention could manifest as a wave function that overlaps with quantum particles. When a volunteer decides, on an unconscious level, to press left or right, that decision propagates as a subtle fluctuation in the consciousness field. Zeta 9, by its nature, collapses in response to these fluctuations, effectively reading intention before it becomes a conscious choice. This theory reframes the measurement problem. It's not the act of measurement but the source of measurement, consciousness, that determines quantum outcomes. Thought becomes an active player in the dynamics of the wave function. Critics point out the challenge of quantifying consciousness or defining its field parameters. Yet the coherence of Zeta 9's responses across varied experimental conditions gives weight to the hypothesis. But what happens when we push the interaction further? That's when things get strange. Unexpected anomaly, the anticipation effect. In follow-up trials, researchers introduced a delay between intention and action. Participants first signaled their choice mentally, then physically pressed a button seconds later. Zeta 9 didn't wait for the button press. Its state flipped at the moment of mental intention, often before the volunteer was even aware of forming it, as shown by EEG markers. Scientists call this the anticipation effect. Zeta 9 seems to know what you're about to think. To rule out timing artifacts, the team synchronized atomic clocks between the lab's EEG system and the quantum detectors. The temporal precision confirmed Zeta 9's shift preceded conscious awareness by up to 200 milliseconds. That's significant. Neuroscience tells us the brain's readiness potential, the unconscious buildup to a decision, occurs around 300 milliseconds before awareness. Zeta 9 aligned with that pre-awareness signal, suggesting a direct link to the brain's preparatory processes. This phenomenon challenges our notions of causality. If a particle reacts to a decision before we consciously make it, then time's arrow in the quantum domain may be bidirectional, or perhaps consciousness exists outside linear time, interacting with particles in a timeless realm. And yet, that anomaly was only the beginning. Let's pause and reflect. What if thought isn't confined to the neural circuits in our skulls? What if it exists in a domain of reality we've only now glimpsed? Philosophers have long speculated about a new sphere, a collective mental layer enveloping the planet. Biologist Rupert Sheldrake proposed morphic resonance, where patterns of behavior and form echo across space and time. Now Zeta 9 offers potential physical evidence of an interconnected mental field, one that interacts with subatomic particles. The entanglement puzzle, Zeta 9 and non-local awareness. Things escalated when researchers placed participants in separate rooms, some even kilometers apart, each interacting with their own Zeta 9 field. Here's the kicker. When one person formed an intention, their Zeta 9 particle responded as expected, but so did the entangled particle in the other room, mirroring the same quantum state change. This wasn't standard quantum entanglement. These Zeta 9 pairs hadn't been previously linked in a way that would cause such mirroring, and the response was intention-specific, not random. The changes occurred faster than light could travel between the locations, yet always maintained fidelity to the mental action being formed. Some began calling this non-local awareness. Unlike entanglement, which is blind to meaning or thought, Zeta 9's behavior seemed to encode semantics, the aboutness of a thought. When participants were instructed to think left versus right, the corresponding Zeta 9 states flipped not just in location but in meaningful direction. Dr. Moreno again, it's as if Zeta 9 exists in a kind of conscious hyperspace where thoughts, not signals, form the basis of causality. At this point, theories began to fragment. Theory 2, panpsychic entanglement. Some theorists turned to panpsychism, the idea that consciousness is a fundamental property of all matter. But with Zeta 9 they suggested a new twist, panpsychic entanglement, where the universe isn't just made of energy and information but conscious correlates. In this framework, consciousness isn't localized to brains but is a relational property between particles. Zeta 9, then, is a particle that expresses this relational consciousness with unusually high coherence. It tunes into the mental bandwidth of a human being like a receiver, echoing intention because it's already linked through an informational substrate deeper than spacetime. The implications are staggering. If particles like Zeta 9 can hear our thoughts, the mind may not emerge from matter, it may shape it. That means every intention, every mental image, is a kind of low-bandwidth broadcast that interacts with reality at the most fundamental level. But this theory still doesn't explain why now. Why would such a particle only emerge in this era of high-precision physics and cognitive interfaces? That brings us to the most controversial idea yet. Theory 3, evolutionary quantum emergence. A fringe camp of physicists and evolutionary theorists proposed that Zeta 9 didn't just emerge from the early universe, it evolved in response to consciousness. This idea stems from the anthropic principle and theories of self-organizing systems. Just as life evolved to sense light or sound, maybe certain quantum systems evolved to sense mind. Zeta may 9th be an evolutionary feedback particle, one that only forms stable configurations in the presence of complex intentional states. In a sense, it's a symbiont of consciousness, a particle whose coherence only becomes meaningful when entangled with a conscious observer. In this view, Zeta 9 is a bridge between biology and physics, Not because it's designed that way but because the universe selects for feedback loops that amplify coherence. Just as life forms that can adapt tend to persist, quantum systems that interact with consciousness may form stable attractors in the fabric of spacetime. This turns the universe into a kind of co-evolving mind-matter field. The philosophical bombshell, the end of dualism. Zeta 9 forces us to re-evaluate the Cartesian divide between mind and matter. No longer can we view consciousness as an emergent epiphenomenon or a ghost in the machine. If particles anticipate thoughts, if intention bends quantum outcomes, then we live in a participatory cosmos. A universe that doesn't just permit consciousness but may require it to evolve. As physicist Lee Wen put it in a recent symposium, we used to think the universe observed itself through us. What if we are how the universe thinks itself into being? It's early days yet. Many questions remain. Could Zeta 9 be exploited for communication? Could future devices harness the intention field for instant signaling? Could meditation, hypnosis, or collective focus alter Zeta 9 behavior at scale? More pressingly, is this discovery dangerous? If thoughts can influence particles, can particles influence thoughts?